So today's topic is loss of resistance. Already we learned that resistance depends on three factors. First one, nature of material. Nature of material. And number two, it depends on its length. And also depends on its cross-sectional area. Cross-sectional area. So let us see how it depends on nature of the material. How it depends on nature of material. Say this is a circuit and this is a resistor. The wire which offers resistance is called resistor. Here in the circuit there is a battery and I have one switch here, or you can say it as plug key, and here I will connect one ammeter in series to measure the current. It is ammeter to measure the current. This is a plug key or just like a switch. And this is power source or battery which is giving the power to the circuit. And this is the resistor which offers the resistance. Okay. Now I will take the resistor. This is now made up of, say, iron. And I will close the plug key and I let the current pass. And let the current pass. Now it is measured in the ammeter. Let us say it is 5 amperes. How much? 5 amperes. Now I will replace this iron resistor now with the same length, but the material is differing now with the copper. Now again I will close the plug key and I will let the current pass. And now when it reaches ammeter, it is measured. Now the current measured is 10 amperes. So why it differs means the resistance of the conductor depends on material. Iron offered more resistance, so less current is observed or measured, but copper on the other hand offered very less resistance to the current, so more current is observed. So with this we can prove that resistance of a conductor depends on material. Do you understand? Now let us do another activity to prove that the resistance of a conductor depends on its length. I will keep this circuit same. Okay. Now say its length is now 5 centimeters made up of, say, copper. And I will close the plug key now and I will let the current pass. Now the current is measured in ammeter. Let it be now 6 amperes. This is recorded as 6 amperes. Now what I do, I will increase the length of the resistor. Now it is 10 centimeters. Now again I will close the plug key and repeat the same procedure. So the current passes like this and it is recorded in the ammeter. Now it shows only 3 amperes. Why? Why? Because the resistance of a conductor is directly proportional to its length. So if the length increases, resistance also increases. If the resistance, resistance is nothing but opposition to current. So current will decrease. So with this we prove that resistance of a conductor is directly proportional to its length. Resistance of a conductor is directly proportional to its length. If resistance increases, so the length increases, the resistance also increases. So the current decreases. Okay. Now we shall go for another activity which proves that resistance of a conductor depends on cross-sectional area. I will keep the length now same, is only 5 centimeters, and now I will say let its cross-section area is 1 mm square. Thickness or cross-section area is 1 millimeter square. Now I will again close the plug key and let the current pass. Let the current recorded in the ammeter is 5 amperes. Now I will replace this wire. I will keep the length same, but I will make the cross-section area double, 2 mm square. So then I will again close the plug key and let the current pass. Now again the current recorded in the ammeter is now 9 amperes. Why? Why? Because resistance of a conductor is inversely proportional to its cross-section area. If cross-section area increases, the resistance decreases. So current increased. So this is second law, the second equation, and we have the first equation, R is proportional to L as first equation. By combining these two equations we have R is proportional to L by A. Let it be third equation. Then R is equals to rho L by A is the fourth equation. What is rho here? It's a proportionality constant known as resistivity. It has another name, specific resistance. Okay. Now, what is this specific resistance or resistivity? Now, resistivity. What is this resistivity? Resistance of a conductor of unit length and unit area of cross section is called the resistivity. We know that from this R is equals to rho into A by L. When the area is equals to 1 unit and length is equals to 1 unit, then rho is equals to R. So the resistivity of a specimen of unit area of cross section and unit length is nothing but specific resistance or resistivity. According to the formula, the units are: resistance is measured in ohms, area is measured in meter square, by length is measured in meter, square cut, meter cut. So we have the unit of resistivity R ohm meter. Resistivity depends on different factors. That is length. Resistivity varies from material to material. Depending on the resistivity values only, the various applications are there for the daily life. So what are those? And before that, the reciprocal of resistivity is called conductivity. Symbol is like this, sigma. The values of resistivity of a material determine their conductivity. Metals with low resistivity behave as good conductors. Metals with low conductivity will behave as good conductors. Okay? Metals such as copper are therefore used for making electrical wires. You know that there will be filament in the bulbs. If you take a bulb like this, there is a filament. Okay? So this filament is made up of tungsten. Why it is made up of tungsten? Because it has higher resistivity and higher melting point. Its resistivity of tungsten is 5.6 into 10 power minus 8 ohm meter, and it has a very high melting point of 3422 degrees centigrade. So because of these two qualities, tungsten is used as a filament in the electrical bulbs. The values of resistivity of insulators are very high. The resistivity values of insulators is very high, in the order of 10 power 14 to 10 power 16 ohm meter. Alloys like nichrome, nickel, chromium and iron combination is called as nichrome. Nichrome combination is nickel, chromium and iron. I mean Fe. And manganese, another alloy is manganese. Manganese is having copper, manganese and nickel. Copper, manganese and nickel. So these have 30 to 100 times. These have 30 to 100 times more resistivity than metals. So alloys are used generally as filaments in the electrical irons, toasters, etc. The resistivity of materials of semiconductors, the resistivity of semiconductors is in order of 10 power 5 to 10 power 10 ohm meter. And we know that semiconductors are used to make diodes, transistors, and integrated circuits, IC, integrated circuits. The ICs are nowadays used in all sorts of electronic devices, including computers. ICs are used in computers, TV, etc.